and mask this one, and you can see how it is connected. Okay, where this is going, okay, it's pretty straightforward in this section. Okay, so one is here. Let's start from this one. Okay, then we'll see if we can. Then this one. Okay, so where we have stub, we'll remove that, otherwise later we'll forget and this will create problem. Okay, so this is going here. To connect this, we have two options. Either we can go like that, and I guess this would be better, because see, if I route it from here, something like that, then all these connections will be kind of closed, right? And we can't able to avoid the multiple via placement. So to do that, we'll follow this path, and if it will create problem, we'll later adjust that. Okay, let's select another one, and it is going here. So for this, if I follow this way, again it will kind of block all the connections. Let's follow this as the same longer path, because at the end this is not the maximum length, because all the length is when we're going to route the third and fourth byte group. Maybe the template or the connections for reference I'm going to give you, those will have different connections, but those will be the perfect one, because I've invested a lot of time to route those. So I would recommend, instead of following this one, you can follow that one. Okay. Apart from that, let's see another one, which is this. Okay, so this we can route on this section. Let's see another one, which is this one. Okay, so this is here. So best way to route those is in this way. If I'll do that, okay, so it will kind of tricky. We have to create some space in this section. Okay, let's see if we can route it like this. Okay, we'll adjust that later, because we have a lot of space in this section as well. If it will be not utilized in later connections, we'll make it proper. Okay, let's go to the another one. Okay, so how it is, okay, it is pretty straightforward. So let's select that. Okay, go for another one. Okay, this one is also kind of straight. So to do that, instead of, I'm going to create some space in this section, and just remove it. Because okay, now we have enough space, right? Okay, so this will be connected like this. Okay, now we have few differential connections and one differential connection and another one. So for differential we'll follow the same way. How to do it? So firstly remove the stubs. Okay, so for this, okay, firstly remove all these connections, which is kind of creating some width related issues. Then place those close here. Now select the differential net, sorry, differential routing and connect those, right? Now we'll change the layer, select one of these, go to the layer 10, backspace, okay, so this will be routed in this section. So before routing those, we have to just remove things from here as well and just route them properly. So to do that, you have to select the interactive differential. Just hold the control key if you can't able to, you know, kind of control the routing or connections. Hold on. Okay, for them we're going to follow the same procedure that we did for the previous differential one, and we're going to place VRs here. Control C, just copy the VR. Okay, now you can place the connections. So to do that, I would recommend delete this section because we have routed it a little bit closer. Backspace. Okay, so now it's fine. And you can see again we are kind of crossing that overlay that we have placed for each byte group. Okay, and another connection is pretty much straightforward. So you can see we have lot of space to length match. Remove the stuff as well. That's it. So this is our second byte group. Now we can target the another byte one, another byte group. Okay, so for this one, as you can see, we can use the same template. So as we have planned, this one we're going to use the layer one. So just copy this one more time, and layer one is yellow one, right? This, Control C. So how we're going to route this? So it will come like this, right? So we're going to use the VR placement orientation, this one. Okay, and later we'll adjust if required. Okay, similarly we can place for this top layer. So just copy the template, Control C. For top layer I'm going to place in this orientation, and later we'll adjust that. place for these as well. For these one I'm not going to place because we have to remove those later. Okay, that's it. Now we can start the routing again, and that will be layer 1. So you can see this is kind of coming very closer to each other. So to avoid that, what I would recommend, just drag the top layer, remove this. So now we have lot of space to route this net. Okay, so just select one and just start connecting those quickly. So it is going here. So instead of starting from this section, because it will kind of disconnect, see, I have two options. Either I can route like this to follow my orientation that I have decided earlier, but again, design is all about improvisation. So you can see if I'll do that, all these nets will be kind of blocked because this will be here, right? So other way will be to route these tracks around this one, right? So which will increase the length, right? So to do that, press Ctrl Z, and this is the right way to do it. Okay, so this is you have to decide, and similarly go for the another one, and it is like kind of next to this one. So we'll again not follow the other way, which is blocking all the other connections. We'll follow this way and just connect those. Let's go for another one, and this is again kind of same, right? So firstly I'm just going to connect those, then later I'll remove all the stubs. Okay, for this as well, if you want to create some clearance, you can use the top layer for this, and let's connect this as well. Let's remove all the stubs. Okay, let's do the other connections. So start from this. Okay, it's going here, and if I'll do that, let's check where this one is going. Okay, so this is kind of outer connections. Let's do it. If it will create a problem, we'll remove that and find other way to do it. Okay, here we have few more connections too. Okay, this one is here, and another one is here. Okay, let's make those as well. So you will see a problem with this one. I'll show you. These are pretty straight connections. Okay, so again I guess we crossed the line here. So to remove this problem, we'll make it here, and for this one I'll put it here. Okay, so this section don't have any via or any kind of connections, right? Okay, now we have to route few more connections like the clock and the data mask. Let's do that as well. So firstly select the differential signal, let's remove this. Let's make it a little bit shorter. Okay, let's copy this track. copy the via. Okay, now let's see, let's connect the to the layer 10, sorry, layer 1. Now, so we have only way to route these connections. Okay, we have one more way. Either we can route from here to here. Okay, so to do that we have to make some space here. Okay, another way is, what is another way? Another way is we can route like this. Okay, so that will be like the biggest connection of this line, because see, from here to here the connections will be smaller. So this differential line, this differential data mask DQS signal, the data strobe will have, you know, maximum length. So again, if the length will be really high, it will not create problems for the lengthy connection, it will create problem for the smaller connections, right? Hold on. Yeah, so I was saying, so again, these are the smaller connections, right? So if you double click on this one, sorry, you can see the maximum length of this connection, which is so this is the length selected, and this is the maximum length, which is around 520 mil, right? And if you see the length of these tracks, double click on this, it is 700, around 200 mil extra, right? So we have to just, you know, add serpentine on these tracks and match with the length, right? So when the length will be really high, we don't have that much space to, you know, add serpentine, right? So we have to kind of follow that path, which is either it is reducing the 10 mil or 5 mil, whatever it is, but we have to go for the minimum length path. So to make this connection, okay, I guess I need a few more space here. Sorry. I guess this one is enough, right? So we can route like this. Now to do that, we'll follow the same procedure. We'll firstly remove these errors. And just place these connection, okay, as close as possible. And just route the differential track. Change the layer to L1 and let's see. Okay, so we have to connect around it. Okay, so let's click here. So what we have to do, we have to route it on the other way. So to do that, just we have to remove those tracks. So maybe you people have also faced this problem before. So this is a kind of pain to just unroute tracks multiple times. Hold on. Oh, this LTM is creating issue. Okay, now it's fine. Okay, I'll copy this quickly. Control C, Control V. Just place those. Now switch between the layers and connect this. Okay, I guess. Okay, I'll see that. What is the issue? Anyways, we're going to connect it like this as of now. We have one more signal left that we have to connect, and that we can connect like around it. So this one, right? So for that, I guess this one will be the shortest path if you'll calculate, because here we have all the track already routed, right? Let's remove the stubs, adjust the tracks, let's make them proper here as well. Okay, so this is the third byte group, and this is the second one. Adjust that as well. So to adjust it, I have to create some space in this section. Okay, here as well. So here, okay, hold on. Control Z. And similarly here. So here you can see we don't have any byte group. We have all the I2S, and which is isolated with ground, right? So we have enough space to make some clearance between the tracks and adjust the interconnects, right? Okay, so this is fine. This is again the byte group 4 is kind of very easy. So instead of doing that, I'm just going to give you a few instructions, like what are the things that you have to complete by your own, and that is your assignment number 9, right? So to do that, again, the first thing, before starting anything, you have to just add this differential pair class on all of the differential tracks, right? So for example, if you see on this one, right? So we face this problem, right? So you will face same problem for this one, for all the EDPs, all the MIPI connections, right? So see, these are the N and P. So you have to cross this like that, right? And then you can place the VRs, right, for the layer change. So to crossing that, you have to just apply this net class, okay? So on the differential track. So for assignment, what you have to do, the first thing, start with the differential pair net class assignment. Net class on each differential pair used on schematic. Okay, what next? So after assigning that, you can able to route all these 6 connections, right? So again, firstly, I would recommend just complete. So again, this would be little bit easy because it is kind of very close to this one, so you can easily route those. Yeah, or you can you can leave this one for reference design, because for this the connection will not be straight, like it will not be like that. I'll put some I'll use this space for these connections, because during the length match we needed space, right? So we have to plan that from the beginning, right, rather than do it later. So yeah, apart from this byte group, you can route the other byte groups. It would be really easy as compared to this one. Okay, apart from these byte groups, you'll see all the EDP connections, right? So it is really straightforward. You have to just place some VIA here, okay, route the differential track on the layer, any layer you can use. You can use L1, L2, L3, any one out of these, right? Because I've routed all these connections on one layer. So you can use any layer to place those, it would be easy, right? So how to do that? So again, firstly you have to place VI in this section. I can demonstrate, right? So let's select the differential one. Okay, So again, if you can't able to follow the grid, like it is going here and there, and some steps are coming out, to avoid that, hold the control key so you can route in grid way. Okay, so use that. Hold on. Yeah, now, so again, you can't able to copy that small connection. You can route one small one, Control C, and you can place the same on this as well. Okay, now place the via. Let's suppose I'm going to use the layer 1, so place it, and those two vias will be for 1 to 8, right? Sorry, 1 to 6. Okay, sorry, hold on. This is on the bottom layer, right? So that will be 12 to 6. 12 to 6. Okay, now you have to do the same thing on this one. So wherever it is, suppose it's here, right? So select the top layer. Firstly, it's differential one. Drag the differential connections, right? Route the small stub. Okay, so by holding the control key only, you can able to follow the grid. Okay, otherwise it will be just either you have to remove the these snaps. Now, okay, so place the via for this as well. Let's do it from here. Okay, and that is from sorry, via type will be from top to 6. Okay, copy the same, paste it here. Now how this will be routed? If you'll see, it will be pretty straight connections for all these differential tracks. Okay. So just follow this path. Right, so this is, you have to connect. So firstly, what I would recommend, like select the EDP group. Okay, that's why I've assigned these groups, right? It would be really easy to make those connections. Select this group. Now firstly, route all the differential tracks on this and place these vias, right? You have to just copy these, copy this and this section, and on those differential track you can place this section, right? After making all those connections like this, then you can start the same thing on this one and just connect those directly quickly. Some will be connected from here, right? Some will be connected. So again, you can see we have one connection here as well, right? So those will be routed like this, okay? So again, you can see what we are doing. We are basically crossing that vertically, right? Rather than doing it horizontally, right? So it is again kind of designing consideration that you can follow. So whenever you have to you can't avoid the crossing the connection, just cross them vertically rather than making it so much parallel, right? So that you can do. Similarly, you can HDMI group, so those connections will be coming like this from here to here, right? And apart from that, we have some these connections are pretty straightforward, right? It will be connected like that. Okay, so what you can do, you can route all these connections, whatever the EDP connections on the layer 1. For these connections, you can use the layer 2 or layer 3. So you can kind of route those from the same path. Apart from that, similarly we have MIPI. So again, these are, I've already routed those. These are all the outer connections, so you don't need to worry about the fanning out those and things like that. In this section, it is little bit tricky to route because here we have some connections at the middle and you have to fan out those. And those connections are following the, have you guys heard the T connections and all those stuff? So that we will discuss on the next session. So just try as much as connections. I mean, only the simplest one if you can route those. And here, what is the reason of giving this much space on the system on chip? Because they know this is the differential track for MIPI, right? And we needed space for making those differential tracks and fanning out those with the pair of vias. So that is why they have given this space. So you can use this space to place those differential VRs and route them directly, right? Similarly, this is pretty straightforward. Okay, so whenever the layer is crossing, if you have routed something on some, I don't need to tell you this thing, right? So you can change the layer and route those. Type C, okay, so this is the type C, which is type C0 that we are using for the programming and debugging. So that will be going here rather than on the 260 pin connector. Type C1, so see, that's why we have used type C1 here, because see, type C0 is going in that direction and type C1 is going in this direction on the 260 pin connector. So that's why it is here, right? So there is always a reason behind the selection of if we have multiple channels for things. And these are the USBs, you can connect those directly, right? So again, I would recommend just try these signal groups and try to connect those rather than LPDDR4, and when I'll give you the reference design, you can follow that. So till here, any doubt, people? And this is it for the today's session, and in the next session we will discuss the length matching for all the high-speed tracks wherever it's required.